In this video, I explain first the Inertial Measurement Unit IMU, ISM330DHCX breakout board that contains an accelerometer and gyroscope. This motion sensor provides an I2C interface, allowing us to communicate with the sensor using the I2C protocol by connecting the sensor to a microcontroller or any other device supporting I2C communication. We can read data from the accelerometer and gyroscope, configure sensor settings, and control its operation. Here I present the cabling between the IMU sensor and a SparkFun redboard Artemis Nano microcontroller, and we'll discuss briefly how to install the library and run the system in the Arduino Integrated Development Environment or IDE framework. Let's dive into this protocol. In this video, I explain only the technicalities behind the interconnection of the redboard Artemis Nano with the 6 degree of freedom inertial measurement unit. The STEVAL-MKI207V1 is an electronic board developed by ST Microelectronics. It features the ISM330DHCX, which hereafter I call IMU sensor. This sensor contains a 3-axis accelerometer and 3-axis gyroscope module. The ISM330 is a MEMS or micro electromechanical system sensor designed for motion sensing applications. This motion sensor, as mentioned, provides an I2C interface which allows communications under the I2C protocol, which again enables easy integration of sensor into various applications and projects in order to retrieve the motion related data such as robotics, motion tracking, gesture recognition, and more. However, my main interest is to extract ocean wave information from the IMU measurement that I will explore in another video. A general overview of I2C serial communication has been given in another video that you can find the link here or in the description of this video. But I briefly remind you the concept. In this communication protocol, only 2 wires are used. Serial clock line or SCL and serial data line or SDA. Before starting discussion, it's important to consult the ISM330 datasheet or programming reference manual provided by ST Microelectronics for the specific details regarding register addresses, data formats, and any additional considerations for the I2C communication with the sensor. To read accelerometer and gyroscope data from the IMU sensor, we typically need to follow the listed steps here. Initialize the I2C bus and connect the microcontroller to the IMU sensor. The master microcontroller sends a start condition on the I2C bus and transmit the device address. The address is typically specified in the data sheet and consists of a 7-bit value followed by a read and write or write bit, which in our case is just read. After the IMU sensor confirms receiving this data from the master, we start reading the data. The sensor will send the requested data over the I2C bus, and the microcontroller should read the data bytes accordingly. In the case of acceleration and gyroscope data, we will likely apply few processing on raw data, like data format, to convert data to meaningful acceleration or angular velocity values in gyroscope measurements. The process of reading data is repeated as needed. Finally, the microcontroller is set to stop condition. As mentioned, we use the SparkFun redboard Artemis Nano with schematic as shown here. You can find details on how to read this schematic in another video with link here. For the I2C communication, we use the quick connector, which consists of 4 pins with power, ground, and 2 I2C communication lines, namely SDA and SCL lines. To establish a physical connection between the ISM330 sensor and the redboard Artemis Nano, we typically need to connect the appropriate pins of the sensor to the corresponding pins of the microcontroller. Here I provide a general guide for the cabling between the IMU sensor and our microcontroller. I explain first different wires we need in our project. We use for this communication 4 wires for VDD, ground, SDA, and SCL. I use the quick system that relies on a specific connector and cable as shown here. The quick connector is a 4-pin connector that provides power and I2C communication for the modules. The quick wire is a pre-assembled cable with a quick connector on one end for our application. It consists of 4 wires, VCC, power, GND, ground, SDA data, and SCL clock as color coded in this table. Now we are ready to connect the IMU to the microcontroller using the wires I've introduced. First, we set the physical locations of the IMU sensor and the microcontroller as shown here. Now, connect the 3.3 power supply pin of the microcontroller to the bus line to the plus line on breadboard here. Connect also the ground pin of the microcontroller onto this row here. Connect the VDD pin of the ISM330 IMU sensor to the 3.3 volt power supply pin of the microcontroller. Connect the quick wire. Connect the ground pin of the IMU sensor to the ground pin of the quick black wire. Connect correspondingly the quick red power cable to the 3.3 volt power. Now connect the SDA pin of the quick blue wire to the SDA pin of the IMU sensor. Connect the SCL pin of the IMU sensor to the SCL pin of the microcontroller using the red color, the yellow color quick wire. Connect the chip select pin of the IMU sensor to the 3.3 volt power. Finally, verify the connections and power up the microcontroller and the IMU system sensor. Here is the completed physical connection between the IMU sensor and the breadboard Artemis Nano. In order to read accelerometer and gyroscope data from the IMU sensor, we need to install the required software libraries that I'm going to elaborate very briefly here. C libraries or software development kits, SDKs of the ISM330DHCX can be found on platforms like GitHub. These libraries provide pre-written codes and functions that make it easier to interface with the sensor and access its data. Alternatively, you can add a library to your Arduino integrated development environment IDE by searching for ISM330DHCX in the Manage Library window. If the library is found, just install it. You will get then examples on how to use the IMU sensor in file examples of IDE software. Now we connect our measuring system to computer or laptop by opening the IDE and selecting the USB port. We then choose which external board has been connected to the USB port as shown here. We select the redboard Artemis Nano. We are now ready to program the microcontroller. We can open the example related to the IMU sensor or develop our code. Here you see a sample C program on how to read data from IMU sensor through I2C protocol. I have provided a short video to show you different steps.